Okay, this video is about differentiation. Differentiation is the process that we use to find the gradient of a point on the curve. So here I've got a curve y equals 3x squared. So you can see by looking at this, if you draw a tangent at different points, completely missing here, but if you draw a tangent at different points along the curve, the gradient is different. So the gradient changes at different points of the curve. So we don't have a set gradient for a curve, we have a gradient function, and that's what differentiation gives us. So if y equals 3x squared, we're going to work out dy dx, and this is the notation that we use in differentiation. So the gradient function, the function that tells us the gradient at a different point on the curve, is called dy dx. And there's a very simple process that we follow to find the gradient function. So all we do is we times by the power, and I'm going to give you a few examples of what we mean by this in a minute, times by the power, and then take 1 off of the power. So we're going to times by the power and take 1 off of the power. So we're going to, the power, we're differentiating the x's, and the power is 2. So we're going to times by 2, so that will give us 3 times 2, which is 6, and then we're going to take 1 off, so it'll be x to the power of 1. Now we don't need to write the power of 1 on an x. If we just write x, that means x to the power of 1. So the gradient function of this curve is 6x. So if you want to know the gradient at any point along the curve y equals 3x squared, you've just got to substitute your x coordinate into the 6x. So if you want to know the gradient when x is 1, you just substitute 1 in. So when x is 1, dy dx is 6 times 1, which is 6. When x is minus 2, dy dx, the gradient, is 6 times minus 2, which is minus 12. So you can see the gradient is changing, and it's going to be different depending on what x coordinate you put in. So you can work out the gradient of any tangent or any point along the curve by working out dy dx, by working out the gradient function. And so this is differentiation. So let's have a look at some examples. So we've got 4 different curves here, and we're going to work out the gradient function. We're going to work out dy dx for each of these. So dy dx, and we're just following the process. We're going to times by the power and take 1 off the power. So times by the power, 3 7s are 21, and then taking 1 off the power, 3 minus 1 is 2. Times by the power, 2 times 8 is 16, and take 1 off the power, which is x to the power of 1. We don't need to write the 1. Then we go here, dy dx, so we times by the power, 2 times 3 is 6, and take 1 off the power, which is x to the power of 1. And here we've got x to the power of 1 already. I'll put the 1 there. So 1 times 5 is 5. And then we take 1 off the power, which goes to x0. And x0, we don't write x0. x0 is going to be 1. So 5 times 1 is just 5. So if you've got 5x, that will differentiate just to 5. If you had 7x, it will differentiate just to 7. If you had minus 3x, that will differentiate you to give you minus 3. So whenever you've got 5x or something x, the x just disappears. So down here now, dy dx, times by the power, and take 1 off the power. Times by the power, take 1 off the power, and at 8 by itself, if you think of it as x0 now, and you multiply by the power, it's going to disappear. Anything times 0 is 0. So whenever you've got a number by itself, it just disappears. And dy dx here. So 2 9s are 18. 2 minus 1 is 1. 1 5 is 5, and 1 minus 1 is 0, so we're not going to write x 0, and the 2 is going to disappear. So whenever you've got something x, it just goes to that something, and whenever you've got a number, a constant, it's going to disappear. So this is the process of differentiation. So let's look at a few harder examples now. So we've also got this different notation over here. So we've got fx instead of y. They mean the same thing. So think of fx meaning exactly the same. It means a function of x. So it means the same thing as y. Y is a function of x. F of x is a function of x. So it's think of it as exactly the same as y. We can't differentiate root x straight away. We need to change it into something we can differentiate first. So I'll write fx again underneath, and I'm going to change root x to x to the power of a half, because the power of a half means square root. Square root means power of a half. So I can switch, I can interchange them, I can change between those. And then instead of dy dx for this notation, we write f dash x. F dash x. So 6 times 1 is 6. Take 1 off the power, 5. Half times 1 is a half. Take 1 off the power, minus a half. Okay, dy dx here. 5 6s are 30. 5 minus 1 is 4. Negative 2 times a negative 3 is a positive 6. And negative 3 minus 1, negative 3 down 1 is negative 4. The number by itself disappears. So to do this one here, we need to divide each term by x squared. So we need to get rid of the fraction first. So f of x is, and dividing by x squared, so when you divide indices, you take away the powers. So that will give us 2x to the power of minus 7 minus 5x to the power of minus 1. And then f dash x, so the same as dy dx, times by the power, take 1 off the power, then times by the power, and take 1 off the power. So it's the same process over and over again. For differentiation, times by the power, take 1 off the power. Over here we need to expand the brackets first. So that will give us x squared minus 2x plus 3x, so plus x minus 6. And then dy dx, the same process again. So 2x, think of this as 1x, which will go to just 1. Okay, maybe pause the video and give these ones a go. So try and differentiate these functions. Okay, here the first one, we've got dy dx, following the same process, times by the power, take 1 off the power. So 6x plus 17. Here we've got to expand the bracket first. So that will give us 6x squared plus 9x. And then we differentiate. Same process again, times by the power, take 1 off the power. Here with this notation, we write f dash x instead of dy dx. It means the same thing. But actually, we should have changed this first to x to the power of a half. So this is 7x power of a half. And then we just follow the same process again. Times by the power, take 1 off the power. 7 times a half is 7 over 2. And then half take away 1 is minus a half. And here we're going to divide through by x squared. So that will give us 5x minus, well, x1 divided by x squared is x minus 1. And 2 divided by x squared is 2x minus 2. And then we differentiate, so dy dx, the same process as before. Times by the power, take 1 off the power. Okay, so here's some differentiation questions. What we've got to do is find the gradient when x equals 2. So we need to find dy dx, which is the gradient function of a curve, and then we're going to substitute in x is 2 to find the gradient at that point. So the first step, we're going to do dy dx, and the process is times in by the power, taking 1 off the power. So 3 times 2 is 6, take 1 off the power, just goes to x, and 17x goes to 17 when we differentiate it. The 10 disappears, so the gradient function is 6x plus 17. So when x is 2, when x equals 2, dy dx is 6 times 2 plus 17, which is 12 plus 17, which is 29. And the second one here, so first step, we're going to find the gradient function. So dy dx is times in by the power, so 15, taking 1 off the power, x squared, and then minus 1, because we've got minus 1x here, the 2 disappears. So when x is 2, we have dy dx as 15 times 2 squared, take away 1, which is 15 times 4, take away 1, 15 times 4 is 60, 60 minus 1 is 59. Okay, so 2 more questions here. Finding the gradient when x equals 1. So we need to rearrange these first before we can differentiate them, so we'll do that. So 2x cubed is already in the right format, 3x squared is fine, and we just need to change 2 root x to 2x half. Now we can differentiate it, so dy dx, following the same process, timesing by the power, taking 1 off the power. Timesing by the power, taking 1 off the power. 2 times a half is 1, and then take 1 off the power. So when x is 1, dy dx is 6 times 1 minus 6 times 1 plus 1. So 1 to the power of anything is always going to be 1. So it's 6 times 1, which is 6. Take away 6 times 1, which is 6. So 6 take away 6 is 0. Plus 1 is 1. And here, so we have to expand the bracket and divide through by x before we can differentiate. So expanding the bracket gives us x squared. So minus 2x plus 3x minus 6, and we need to divide through, so x squared over x is x over x is 1, and 6 over x is 6x minus 1. So dy dx, I'll write it here, dy dx, so it is 1 plus 6x minus 2. So 1x just goes to 1, the 1 on itself disappears, and then minus 6, negative 6 times a negative 1 is a positive 6, and then taking 1 off the power, negative 1 minus 1 is negative 2. And substituting in x is 1 gives us 1 plus 6 times 1, so that's 7.